Okay, so today we're going to talk about derivatives, and this is the first video of my video series. So let's get into this. Here I have a graph of y equals x squared, and so today I'm basically just going to talk about the origin, I guess, of the derivative function. And so basically when you look at this graph, if I wanted to find the slope of this graph at a specific point, like right here, then I could do this by finding the slope of a secant line, which would be the slope between this point and a point very close to it. So maybe like right here. And so if I labeled this x-coordinate as a, then the y-coordinate would be f of a. And then I could label this as b, or sorry, not b. Let's see, undo. Okay, just kidding, erase. I could label this as a plus h, and then the y-coordinate would be f of a plus h. And so by finding the secant line, I would get a line that connects both of these points right here. And so the tangent of this secant line would be f of a plus h minus f of a divided by, so this is the change in y, divided by the change in x, which would be a plus h minus a. And to find the line that is tangent to this specific point right here, let me find a different color. To find, oh, that wasn't very good. Oops. Oh well. Well, basically, to find the line that is tangent to this point right here, I would have to plug in h equals 0. Like, to find the best possible solution would be to use a number for h that's really, really close to 0 or exactly 0. So that would be the limit as h approaches 0. And so this right here is my derivative function. Yay! And so that's what I would use to find the tangent line, the tangent to a point on any of these graphs to find the derivative. So yeah. Okay, so now that we have this, let's do an example. So yeah, if I go back to this, I actually forgot to simplify my equation for my derivative. So the final equation is actually the limit as h approaches 0 of f of a plus h minus f of a over h. So let's see if we can find the derivative of f of x equals 2x cubed minus 1. So, using our formula, which was f of x plus h minus f of x all over h of h plus x, or x plus h minus x, we can plug in our values for x. So we would end up with let's see, wait, what am I doing? Sorry. Okay, we would have 2x 2 times x plus h cubed minus 1 minus 2x cubed minus 1 in parentheses and then you would divide by okay, oops. So I forgot to keep going with my original equation for my derivative. So now I can go back to this and rewrite this bottom part as just h. So down here I would just have an h. So now I'm going to simplify this. It's really gross, but I'm going to do it anyways. 2 times x cubed plus 3x squared h plus 3xh squared plus h cubed. I'm running out of room. Okay. Minus 1 minus 2x cubed plus 1 all over h equals 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 1 minus 2x cubed plus 1 all over h. Then I'm going to keep going. And so here I can cross out this and this because they cancel each other out. Negative 1 and positive 1 cancel each other out. So I end up with 6x squared h plus 6xh squared plus 2h cubed all over h, and then I can simplify even further and get 6x squared plus 6xh plus 2h squared. And then, because my definition is that this equals the limit as h approaches 0, I can plug in 0 for all my h's. And so if I do that, I end up with just 6x squared, because these two have h's, and so those would equal 0. So this is the derivative of f of x equals 2x plus 3. And I would write that in this notation: f prime of x equals 6x squared, and that is the derivative. So yeah, there you go.